Hello friends, in the previous lecture we have seen the effect of multiplication by t along with their problems. So now we'll talk about the effect of division by t, and the statement is if Laplace transform of f of t equal to f of s, then Laplace transform of f of t divided by t, that is equal to integration between s to infinity of f of s ds. So that means Laplace transform of f of t equal to f of s, that f of s needs to be integrated with respect to s between s to infinity. So we will directly talk about the problems. Now here we will have the first problem. Find the Laplace transform of e to the power of minus t sine of t divided by t. So if I compare with the standardized form, like we have e to the power of minus t sine of t, that is equal to, okay, e to the power of minus t sine of t divided by t, that must be equal to f of t divided by t. So very easily we can identify f of t as e raised to minus t sine of t. That is, f of t is e to the power of minus t and sine of t. And as we know that once we identify f of t, if it is in the standardized form, we may directly find the Laplace transform. Since it resembles like e to the power of minus at into f of t in turn, so we can have the Laplace transformation of this. That is, Laplace transform of f of t equal to Laplace transform of e to the power of minus t sine of t. So it is a standard form of first shifting property. Then we know that whenever we have Laplace transform of e to the power of minus t sine of t, which is in the standardized form, so we can have the Laplace transform of sine of t first, that is 1 divided by s square plus 1. The coefficient of t is minus 1. S needs to be changed as s plus 1. So s can be replaced by s plus 1. So in the next step, we can have 1 divided by s square becomes s plus 1 the whole square plus 1, or it is 1 divided by s square plus 2s plus 2. Okay. Now by L of f of t, we may have 1 divided by s plus 1 whole square plus 1 square, which is f of s. So again, we can apply the standard form, that is Laplace transform of f of t divided by t, which is equal to integration between s to infinity f of s ds. So in the next step, we will straightway replace the value of f of s, that is f of s, to be replaced by 1 divided by s plus 1 whole square plus 1, and we can integrate that function with respect to s between s to infinity. So here we will have Laplace transform of e to the power of minus t sine of t divided by t, and that is equal to integration between s to infinity 1 divided by s plus 1 whole square plus 1 square ds. So it will be in the form of tan inverse of a function of tan inverse of s plus 1 between s to infinity. Since the variable is s, first we can replace it for infinity and then s to be replaced by s. So it gives tan inverse of infinity minus tan inverse of s plus 1. And we know that the value of tan inverse of infinity, which is pi by 2 minus tan inverse of s plus 1. And further, pi by 2 minus tan inverse of s plus 1 can be straightway replaced by cot inverse of s plus 1. So the final function is cot inverse of s plus 1. So the result is the Laplace transform of e to the power of minus t sine of t divided by t, that is equal to cot inverse of s plus 1. Now second problem, find the Laplace of cos at minus cos bt divided by t. So let us write, let f of t divided by t, that is equal to the given function cos at minus cos bt divided by t. So from this one can identify f of t, and of course f of t is cos at minus cos bt. Now since cos at and cos bt both are in the standard form, So therefore, we can directly find the Laplace transform. Laplace of cos AT minus cos BT. So we can apply the linearity property, that is cos AT minus Laplace of cos BT. And we can find its Laplace transform, that is Laplace of cos AT, it gives s divided by s square plus a square minus s, again cos bt is s divided by s square plus b square. Okay. Now here, that is f of s, Laplace transform of f of t, that is equal to f of s. Since we are interested in cos at cos bt divided by t, so for that we can have the standard form, that is Laplace of f of t divided by t. It gives integration of between s to infinity of f of s with respect to s. So this particular expression we have considered as f of s. So this f of s needs to be integrated with respect to s between the limit of integration s to infinity. So we can rewrite them. So here Laplace of cos at minus cos bt divided by t, that is equal to integration between s to infinity s divided by s square plus a square minus s divided by s square plus b square with respect to s. Now here further we can split them and we can integrate the first term as well as second term with respect to s between s to infinity. But to proceed further, so we can adopt the standard formulae, the standard form or the standard formula of the integration. So here integration between f dash of x divided by f of x dx. So that means the denominator fx is a function, numerator is its derivative. So whenever we come across derivative of the function divided by the original function d of x, that is equal to log f of x plus constant of integration. So we can adopt the same here, that is whenever we come across s divided by s square plus a square or s divided by s square plus b square, accordingly, so if we can compare interpret s square plus a square or s square plus b square denominator term as a function, the numerator is supposed to be the derivative of that function. So derivative of s square plus a square must be 2s. Derivative of s square plus b square, of course with respect to s, it should be 2s. But unfortunately we have alone s. So to make it as 2s, we can multiply and divide by 2. Okay, so integration between s to infinity 1 by 2 with the first term 2s s square plus a square multiplied and divided by 2. Again for the second same 1 by 2 2s divided by s square plus b square ds. Now each term is in the standard form, that is denominator is a function, numerator is the derivative. Denominator is a function, numerator is the derivative. And we know that whenever we come across this form, we can straightway write, that is log of s square plus a square, again log of s square plus b square. So in the next step, we can further split them, we can separate them. That is 1 by 2 integration between s to infinity 2s s square plus a square ds, first term, minus 1 by 2 s to infinity 2s s square plus b square ds. Next, so here that is cos of at minus cos of bt divided by t. Accordingly, we can write 1 by 2 log of s square plus a square minus log of s square plus b square. So we can integrate between s to infinity. So further we may write 1 by 2 log of s square plus a square divided by s square plus b square between s to infinity. So now if I substitute s to be infinity, and again for both numerator and denominator, it becomes log of infinity. And what is the value of log of infinity? Which cannot be determined. So in that case, we have to adopt some other property, that is we can take s square, both numerator and denominator, as a common factor which gets cancelled with each other. So it gives this particular form, that is 1 by 2 log of 1 plus a square by s square divided by 1 plus b square by s square between s to infinity. Now if I substitute s to be infinity, which is a square by infinity, that is 0. Again b square by infinity, that is also 0. So it is log of 1. Again s needs to be replaced by s only. So in the next step, we can have log of 1 minus log of a square plus a square divided by a square plus b square. Outside is 1 by 2. And what is the value of log of 1? Which is 0. So we can write 1 by 2, 0 minus log of a square plus a square divided by a square plus b square. So further we may write 1 by 2 log of a square plus a square divided by a square plus b square raised to minus 1. Or finally we may write the answer as Laplace of cos at minus cos bt divided by t, that is equal to 1 divided by 2 log of a square plus b square divided by a square plus a square. So this is the Laplace transformation of the given function. So for more problems, you may refer to the link provided in the description. And for any queries or doubt, please comment and don't forget to subscribe, share and like the video. Thank you.